my name is Stacia Conger. I am the State Irrigation Specialist for the LSU Ag Center. And actually what Lyle just presented is going to feed directly into what I'm going to talk about. So here in Louisiana, most of our row crops are going to be in this brown land use. We have a lot of row crops along the Mississippi River here, and then as well as the Red River Valley. And then this is rice country down here with some sugar cane. So if I overlay our water use for irrigation across that map, you can see that our irrigation water use follows that X pattern on the state. Now, I'm one person. I have responsibilities for the whole state. I can't do everything. So I focus actually on corn, cotton, and soybean in this top V portion when I work with farmers. So we've done a number of demonstrations over the last 4 or 5 years. And basically what producers have told me is that we did demonstrations with soil moisture sensors primarily. And we did that because the farmers were asking about it. But when we put them out there and talked with the farmers after the end of the season, they weren't comfortable with the price of implementing that on their whole farm. They also were not comfortable with how the data came out. So they were expecting more of this magic device is going to tell me when to irrigate everything. And it doesn't work that way. You have to know what you're looking at and kind of interpret what's going on for most products. And so I just wasn't seeing a lot of buy-in in terms of soil moisture sensors. And they were seeing a lot of data like this. This is what I'm talking about. They want to know, when do I irrigate? And they're seeing a bunch of lines, and it's just not giving them the trigger point like Lyle was talking about. So when I started comparing all of the information you need to interpret the sensor data and all the information you need to do an irrigation schedule with the soil water balance, which is free, then maybe it would be a good alternative for the people who want to learn about irrigation on their farm without investing so much money. They could play with something if we had an irrigation scheduling tool, which many states provide, but in Louisiana, we don't have one specific for us yet. So my hypothesis was that we could develop a soil water balance to schedule irrigation in the Mid-South. And so my first objective was to develop it. And then my second objective is to look at what data do we have available to put in it. Because as we always hear, garbage in, garbage out, right? So if we're not putting good data in, if we don't have good data available to put in, then there's no point in using it. So here's an image of how the soil water balance works. This is basically a visual depiction. So you have your roots here, and this is the only place where the roots can actually access the water. So if you have water out there and it's not in that box, it's not beneficial to the plant. So water is lost through crop evapotranspiration, irrigation, and rainfall that actually enters the box, which we call effective. And then we also lose water to surface runoff and depercolation. So basically, I'm keeping, it's called the checkbook method. I'm keeping an account of all of that water movement in and out of that box. That's all I'm doing. It's very theoretical. There's nothing out in the field to give you feedback of what's really out there. And to use it, you just need to put in your planting date. And if you are irrigating with it, you put in your acres so that it'll convert to a depth for you or a volume. And then the blue is where you can adjust it. So it has suggested values in there for all these things. You could use it without putting anything in. But the more accurate you get to your actual site that you're irrigating, the better it's going to work for you. And then what you would put in on a daily basis would be your ET value, which you normally get from a weather station, and your rainfall value. I designed this spreadsheet specifically with a specific ET equation to where I wanted a farmer to be able to watch the news, see what the max and min temperature is for that day, and calculate an ET number from that. They could also see how much rain they had from the news and plug that in. So I wanted it to be as easy as possible and see if that worked. So we did a number of sensor studies on research stations across the northern Louisiana, and we looked at 2 different sensors. This is the one that Lyle was talking about, the watermark sensor that reads at a potential. We couldn't really convert potential, we don't have that information to convert the potential readings to what would compare to my soil water balance. So we didn't use any of that data yet. So we're focusing on this sensor, which is the GS1. It's a volumetric sensor. So it's going to give me a number that I can compare to my spreadsheet directly. And so this sensor worked the best when we used it on a cotton crop on sandy clay loam, which is in my neck of the woods in Bossier City. So that's the data you see here. And this is very similar to what Lyle showed you. This particular year, we had so much rainfall at the end of the year. That was a very, very wet August. So that's why it looks a little crazy over here. But you can see that all 4 of my depths, no, 5 of my depths, each have a line and the soil moisture is moving. These red lines are my irrigation events. And you can see from the data, if you're familiar with this type of data, that we did not irrigate at the right time. And we knew that. You can see that because there's stress happening here as the line flattens out. That's that stress that what Lyle was talking about, where you introduce that stress to the plant, the line will actually flatten out. So if I average all 5 of those lines, I get one line, and that is my orange line here. So that's my average soil moisture in that root zone from the sensors. My soil water balance gave me the blue line. And a lot of times, like later in the season, they were right on par. But we had an issue here, which kind of stuck with it. And then also an issue here. And really that was an issue with, so when you have a soil water balance, you say, okay, well here's the maximum it can hold in this root zone. Well, I'm gonna say if I get rain, it's gonna fill up that root zone. We all know that not all that water goes into the soil every time, even if you have that available. So there's an infiltration issue that I need to add into the spreadsheet. However, that's to get it like research accurate. If I'm gonna use it as a product, like to schedule my on-farm irrigation, this actually works. So I simulated what the irrigation schedule for that year, that crop season should have been. And it said, that's the yellow line, that's my simulated schedule. And it said I should have had 2 irrigation events, which is technically what I did, but they're at very different times of when I actually did them, which we knew I didn't irrigate at the right time. So we went back to the graph and kind of overlaid this and looked, and where it said I needed to irrigate is right before where my lines started to kind of flatten out. So my soil water balance actually predicted when I needed that irrigation, even though I didn't know it from the sensor data at the time. So now I need to look at what weather data we have available to go into this, because Louisiana has not had a functioning weather network in a good number of years. Supposedly that's changing next week. It's supposed to be released next week. But at the time that we started collecting this data and looking at all this, I didn't have any weather data available. So I need to find it somewhere else. So the weather station network that's going to be coming out next week is going to be a regionally based network. And there's going to be 5 good stations. I think the website's actually going to report on 7. There's going to be a few more in the southern part. But we're pretty sparse as well. So getting a value that's farm specific, we're going to have to look to see if these weather stations can actually do that. We're not there yet. So to calculate what us engineers say is the standardized ET equation, it's going to look like this, and it's going to have all this data. And that's just not feasible for anybody to be doing that but me. So we looked at using atmometers to estimate that ET value. And so these are just tubes with a data logger that we connected to our data logger here. with water in them, and there's a little clay surface on the top with a piece of fabric that's supposed to simulate the transpiration from a leaf. And so over time, water will evaporate from these, and it estimates how much is evaporating over a certain amount of time. So I could get an ET rate from these, but we wanted to see if they worked in our climate and what we had to do to actually use them. So I partnered with Dan Fromme at the Deanley Research Station. He put out 3 atmometers next to one of our new weather stations. I put out 3 next to one of my new weather stations where I'm at, and we took a look at what was going to happen. So here's my location. This is cumulative ETO from those 3 atmometers, and this black dotted line is what I calculated with that big long equation from the weather station. And cumulative values are going to show you, like if you have an error somewhere, like you can see we're starting to deviate here, that error is going to compound. So the farther apart the lines are, the more compounding error you're going to have over time. So we did have some deviation with the atmometers themselves, but we were mostly deviating from that ASE method. So then I looked at weekly, because I wanted to see what was really happening on a weekly basis. And you can see that right here we're kind of on par, but then somewhere, this is around mid-May, I believe, we start to over-predict from the standardized equation. And by the end of the season, we were pretty different. But I'm like, okay, well, we're different than the standard. Well, what's that going to do to my irrigation schedule? So I went back to that spreadsheet, and I used the standard equation, and I used one of my atmometers and looked at the difference in the irrigation schedule. And that error actually increased the number of irrigation events. So if I had used the atmometer, I would have had 3 events, but if I had used the weather station, I would have had 2. So that error did add an extra irrigation event in the schedule. So Dan Fromme had a little bit more trouble with this than I did. His were all over the place. I'm just kind of showing you all the error there that happened. They just would stop working for him, and this had an ET value of like 5 inches one day, which is impossible. So we're gonna have to work a little harder to get his to work this year. He talked about replacing them actually. But using his best one with the error removed. Oh, and here's the weekly, I'm sorry, I skipped ahead. So with the weekly, he was over predicting from the standard equation the entire season. And that could be, I would say that's more of a regional thing, but we need to figure out why mine deviated later in the year. At his weather station, he had a working rain gauge. We also installed rain gauges separate from the weather stations. The one at my station wasn't working, so I couldn't compare anything. But at his station, the blue is the weather station's rainfall, the orange is what we measured. And we're using a tipping bucket rain gauge. And if you know anything about those, if they're gonna err on the side of less rainfall. Like, when rain comes in sideways, it's not gonna go in the bucket, that type of thing. So if I was to trust either one of these of being more correct, I would trust ours than the weather station. So just to give you an idea, if you're going to use rainfall from one of our weather networks, it may be a little less than what you actually got. Rainfall is also very regional, so if you're so many miles from our weather station, it's probably not going to be accurate either. So we had a 26% increase in rainfall measured from our rain gauge. Okay, so when I did the irrigation schedule, his was overestimating ETO so much that he had 4 irrigation events when mine only predicted 2, if I use the standardized equation. So this actually added 2 extra irrigation events that we may not have needed by using the atmometer data. Now, it doesn't mean atmometers are bad. It just means those numbers that I put that you can edit in the blue boxes are gonna need to be adjusted to use the atmometer data. And we have no science to help you do that.
Were those atmometers, did they have the sight tube, or were they just
They do.
internally reading?
We use the data loggers, but they do have the sight tubes, and we made sure that they were accurate at the beginning of the season. We needed to make sure that they were accurate at the end of the season, and we didn't do that. So that'll be part of, we're gonna repeat it this year. So we're gonna do that this year. Okay, so the soil water balance as a scheduling tool, like a practical tool, was working for us. But we still need to work on making sure that infiltration becomes a factor, because we didn't have a ton of rainfall in the data I showed you. But if we have a rainy year, that's gonna really mess up the schedule. So that's something that we need to add to it. Also, having a healthy soil system is very important. Lyle talked about it. If you have an unhealthy crop or an unhealthy soil system that produces an unhealthy crop, you are not gonna have the infiltration, you're not gonna have the water holding capacity, and it's gonna mess this all up. Like you're just not scheduling anymore. And we still need to work on getting good information. And we're still determining we're still working on this ETO data. So basically we need to adjust the crop coefficients for atmometers if they're gonna continue to overpredict ET. And then we need to look at the rainfall factor and see if that's gonna be an issue long-term. Any questions?
So you prefer the atmometer data or weather station? Which of them you?
I will, as an engineer, I will always prefer the standardized equation, because that is what's accepted as the standard for ET prediction. And when you have a standard, it helps everyone understand that they're starting with the same baseline, and then they can adjust based on their local conditions. Whereas when we're all using different estimating factors, then there's no way for me to say, hey, you need to do this with your crop coefficient if you use that data, because I don't have a standard. Does that make sense?
No.
Oh.
Just, I just suggest to you that I measure the atmometer data and the weather station data, and plus I use the standard weather pan. We use pan, the big 3 feet.
The evaporation pan?
Yeah.
So that's gonna underpredict. It's not ET, that's evaporation. That's only the E.
It's ET. You can calculate your concentration data. So you can compare all three of these, and then you can. For me, I think it's more accurate is atmometer data than the calculation data. Just you can compare it, and you can see.
Accuracy is a hard term to quantify here because there's no baseline.
What about the rainfall data? Which of them you prefer?
So we didn't evaluate rainfall data here.
So we have data, the rainfall data, there are big differences between measuring and between weather station, right? So
rainfall data is all over the place, no matter what you use or how you use it or where you are.
you use the same place, right?
So the only place we had the same,
The slide with the rainfall.
there was one location where we had duplicate.
26% difference is too much.
Yeah, I agree.
Yeah, maybe you measure. I don't know if there is some errors or weather station measures with the error. Which of them you prefer?
Well, like I said, a rain gauge is only going to underestimate. It's not going to make up rainfall data. So if it's going to err, it's going to err on the side of under predicting. So I'm assuming the orange line is more correct than the blue line. Yeah.
You by chance look at like climate and what they may have predicted for field by field?
I haven't, but that's a good idea. So in the future, we're gonna look at other weather sources, not just what we have here. And so I wanna bring in the National Weather Service data. Climate is a good option because I know a lot of producers are using that as their source for weather data. I have looked at farm logs, and I've found that their data changes over time. And I'm not quite sure why, I haven't looked into it. But if I pull it today and I pull it in 2 months, it's gonna be different. So,
I think they go back and look at actual rainfalls reported, and they use their algorithm to the cloud cover and the density of the clouds, and
yeah,
then it's never gonna be the same 24 hours after the first report.
so is that it just within that 24 hours it changes, or?
Well, they're collecting more data from ground stations and comparing
Okay,
what they know fell in that event.
yeah. So that's gonna be the future of this, is pulling those different sources and seeing how they compare. Any other questions? Thank you.